grade 10s, we are here. It is a Tuesday. I can't believe it's my first show with John, and I'm so excited because I used to watch him all the time, and now I'm actually here doing a show, presenting with him. It is a fantastic day. I'm so glad to be here. How have you been, John? Good.
I'm really good, Megan. I can't believe it. I thought we'd done a show together. But anyway, guys, grade 10s, welcome to this time slot. I know that you've moved up. Grade 11s, if you think this is a grade 11 show, no, don't go away. Don't you dare put that TV off. This is important stuff for you to know as well. The grade 11 show's coming up after that. Isn't that right, Megan?
Exactly. And it's all been turned around because matrics have revision during the day. So, you know what? This is your time, and this is your time to shine. But first, I have so much to tell you. You guys all know that Samsung have proudly sponsored Mindset with fantastic new content on our Learning Hub. So let me just show you what it's all about. This thing fights with me sometimes. So basically we have the exam content over here. You do revision. Revision is uploaded daily and free content, so please check it out. And the videos are here. So how fantastic is that, with technology and knowledge all here bundled up into one? And there we have the Learning Hub. But it's only for premium smartphones and Samsung tablets. But don't stress, Mindset, is because you know what? Now is the time to enter. I'm sure you've heard about it. The Learn Extra Exam Revision Marathon Competition. Woo, long sentence, but basically, look, download the notes at mindset.co.za/Learn Extra. Look for the race number, go onto Facebook and enter, because you know what? You only have to enter once and you'll be drawn and thrown your name into 9 draws. So, you know what? You could stand a chance to win one of these fantastic Samsung tablets. But that's all I have to say. Please enter. We need 200 more entries. We could have it on this show. We could have it on the next show. Make sure you guys enter. And with that, John, take it away.
Right, guys, before I get into that, I just want to remind you, today we're starting our grade 10 exam revision. Now, I know lots of you were saying, and you've said, why is it not fair? We don't get exam revision, we don't get spring school, that's for the grade 12. So we've designed this spot specially for you. So please send in your questions, post them on Facebook, send them to the help desk. Make sure that you're starting to prepare for your exams now. I know they're in a couple of weeks' time, but let's get going with exam revision. Today we're going to be covering the topic of matter and the atom, stuff that you covered at the beginning of the year. But don't forget, we need to go over this. So make sure that you're up to date. Now, I'm going to start by taking some questions from the exemplar paper that was put out by the DBE, and we'll take a look at some things, not just to answer these questions, but so that you can get used to the style of questions you could expect at the end of the year. So get your books ready, make sure you download those notes. Before I go on to this question, I want to just remind you about how to download the notes, because I get your emails from the help desk, and I notice some of you are struggling to both enter the competition and find out how to download the notes. So I'm going to show you how. I'm going to go to the website, and I'm going to click on that button. There's the website. So if you go to www.mindset.co.za/learn, or you go to learnextra.co.za, you will get to a page like this. And you've got different choices: Learn Extra Live, Learn Extra Lessons, Learn Extra Exam Revision in the orange. You used to go to Live. We're now in Exam Revision. So if you go to Live, this is what it used to look like, because we were doing all of that stuff during term, up till last week. Again, the principle is the same. You know that you've got this this blue box here. Oh, I've just highlighted it and my pen's not working. Let me try that again. And I'm going to try it at a different place. I'm going to try it over here. No, it's still there. That blue box, that says notes. I'm just highlighting it there. That's the short link to get the notes. Now, if you click on any of those blue boxes, the notes will come up. It's important that you do that, because at the bottom of today's notes, you will find the race number that you're going to need to put on your entry form. Okay, to make sure that you're on the right page though. This is the page you want to be on, not on the live, but on the orange one, the one that says October. Let's just make sure that we've got it right. It's going to be that one that says exam revision. and we need to see that it's grade 12 in the morning, and it's got grade 10 in the afternoon and grade 11 in the afternoon. Click on the blue box and make sure you answer it. Okay, we'll come back to that a little later in the show just to show you. Okay, guys, let's get going. The notes are up, and we're ready to roll. So here's a match the columns type question. Usually we start off with either a multiple choice or a find a term, define a term, give one term for, or a match the columns. Could be any one of those. Guys, these are easy marks. You need to follow the instructions though. And so I'm going to explain that to you and just mention that within this question, it says only write the letter and the question number, and it gives you the example in your answer book. So when you get your exam, it might be different to other exams that you've written. You might not have an answer book, you might have an answer, but read the instruction. In most cases, in like the grade 12s, you will have an answer book. You must make sure that you answer the question where they tell you to it and how they tell you to it. Don't go and fill in the words and match them up into a sentence. It says just put the question number and the letter. So we're going to do that. We're going to make sure that we go through it. Now, what's the trick for answering this type of question? So they give you column A, column B, and there are a whole lot of words or phrases in column B and sentences or descriptions in column A. Your question is, how do I match them? I've got to match the one to the other. Different people have different techniques of doing it. So let's make sure that we follow a logical sequence. What I'm going to do is I'm going to start off by writing down 1.1.1. And that says potassium chloride crystals. Potassium chloride crystals. What do I know about potassium chloride crystals? Now, guys, I don't just want to give you the answer here. I want to revise a little bit about potassium chloride crystals. Crystals tell us that they're a crystalline solid. That means that they have ionic bonds between them. It's potassium and chlorine. Potassium has lost an electron. Chlorine has gained an electron to form the chloride ion. And so they form this lattice of ions in a solid. Remember, it's a solid. It's not a solution because it says crystals. You wouldn't get a mark for allocating this to a solution. It's not a solution. Yes, we know potassium chloride crystals dissolve when they're placed in water. But that's enough revision about potassium chloride. It is an important salt. Remember, a salt is something that has a metal component and a non-metal component. Right, let's go on. What do we know? Is it a mixture? No, it's not a mixture. So we can eliminate one or two. It's not silicon, it's not sulfur, it's not density, it's not copper. Copper, Cu. So what's the only one that we've got left? A compound. Is it a compound? Potassium chloride. Yes, it's a compound. We know that because potassium's an element and chlorine's an element. Put the two together and you've got potassium chloride, a compound. So now what am I going to answer here, Megan? Am I going to write 1.1 compound? Would I get a mark for that?
No.
What must I do? I must write the letter. I'm going to write 1.1 F. Have you got that, guys? Don't write anything else. Just the question number and the letter. Okay, let's move on to the next one. 1.1.2. And it says a good conductor of electricity. Now, guys, you should know this. What are the good conductors of electricity? Well, we know ionic crystals like potassium chloride can't be conductors of electricity as solids. If we dissolve them in a solution, yes, they will be good conductors because there are ions present. But we've eliminated potassium chloride already. We're not going that route. What else do we know? We know that metals are good conductors of electricity. We know that graphite is a good conductor of electricity, but the other non-metals are insulators. They don't conduct electricity. So the only options that you've got for good conductors of electricity, graphite, it's an exception. It's like the lead in your pencil. It has special arrangement of the atoms of carbon to allow electrons to move through it. But diamond, which is also a form of carbon or coal, doesn't conduct electricity. So we need to be very careful about that. The thing that we need to recognize is that the most common conductors of electricity are any metals. So look at our list now, and are there any metals here? Well, we know that Cu stands for the metal copper. You just have to remember that's the symbol for copper. And yes, copper is an excellent conductor of electricity. How do you know that? How can you remember it? Well, if you just look inside any 3-point plug that's sitting in the wall, take it out and have a look, you'll see that there's some copper wire on the inside. We use copper wire as a conductor of electricity. So my answer is going to be G. I'm going to put that down. Don't write the symbol Cu. It's not. The answer is G, the option for the letter. Next one, a non-metal element. Now, non-metal elements, how do we classify those? Those are elements that are going to be not very good conductors. They're going to be probably from group 14 to 18 on the periodic table. We'd look at those in that region. Okay, so out of my list here, what have I got? I've only got 2 elements left. I've got silicon and I've got sulfur. Now guys, silicon and sulfur, I've got to make a decision between the two. Sulfur is that yellow powder. It has a relatively low melting point. It crumbles. It's a solid at room temperature. We actually know it forms molecules with 8 atoms in it. Okay, so it's a molecular solid. It's not a good conductor, and yes, it is an example of a non-metal. So we know that we can't be wrong if we put sulfur down. Some of you might be saying, but hang on, silicon is also in group 14. It's just below carbon on the periodic table. Why aren't I saying silicon? Well, silicon, if you remember, is one of those semiconductors. It's a group of substances known as metalloids. It's between the metal and the non-metal. It has particular characteristics of some characteristics of a metal, some characteristics of a non-metal. And we use that very special property of silicon in our computer chips. So we need to remember that and revise it. So I'm going to put down my answer for 1.1.3 as sulfur. My answer is number E. Now, remember we've explained what silicon is, and we're going to now just make sure that we don't forget that. Silicon is is not a metal, it's not a non-metal, but it's a semiconductor or a semi-metal or a metalloid. Okay, it's one of those things in between. We'll come to that in a little while. Now, we get on to the next one, and we've got some questions on mixtures. These 2 questions are about mixtures, and we've got 2. We've got sugar dissolved in water, and we've got blood. Now, what do you notice when we put some sugar in water and we stir it up? Megan, you've done this before.
So many times when you make tea.
Oh, absolutely.
Okay.
But just pretend for the moment it wasn't colored with the tea in it.
Okay, so just normal before the tea
Would
bag.
you be able to see, after the sugar's dissolved, would you be able to see any sugar particles in it?
No.
No, it all looks like the same stuff. And so the little particles of sugar, do they bunch up in one region and leave the water in the other region?
No.
No. Even if you take a little drop of sugar, put a tiny grain of sugar, dissolve it in the water, and it's a big glass of water, you put your finger in it, what do you taste?
It's sweet, like sweets, yeah.
Even with a little bit of sugar, guys,
Tiny bit.
that little bit of sugar has thousands and millions and billions of atoms in it. And they spread out evenly, and they form a consistent solution that you can't tell the difference in the layers. Okay? So sugar water is an example of a mixture, because we could make different types. There's not just one mixture of sugar water. You could have, some people like no sugar in their tea. Some people like a grain of sugar in their tea. Some people like 3 teaspoons in their tea. If you like Megan, she probably wants 5 sugars in her tea.
No.
I don't know. No, she won't like that. But she's very sweet, so we don't need to add to that anymore. So let's move on and say, well, because we've got sugar dissolved in water, 1.1.4, let's see what it is. Is it homogeneous or heterogeneous? Okay, guys, homo or hetero. Now, these are prefixes that you're going to have to know. Now, homologous, homogeneous, doesn't matter how you spell it or you say it at least. As long as you get the spelling right, just try and remember. There's a big debate about it, okay? Some people say one and others says another. But if we think about it, the word Homo sapien, the word homologous, okay, is of the same. Those of you that do life sciences, you'll come across something called homozygous and something called heterozygous. These are different. Hetero means different. So homogeneous, heterogeneous, homo, the same. So when we think about sugar in water, it's the same. So we're going to put that down. Sugar in water, it's the same. The answer we're going to use is B. Now I need to rush. 1.1.5, blood. What do we know about blood? Blood is made up of platelets, it's made up of plasma, it's made up of white blood cells, red blood cells, and if we let it settle, we'll actually separate it out into its different layers. So blood is a mixture, and it is a heterogeneous mixture. It's A. Now, we've got two more to go, 1.1.6, and very quickly, increasing conductivity with increasing temperature. Now, normally if we take a metal, we increase the temperature, it becomes harder for the electrons to move through it, or the charges to move through the metal, and we'd say the resistance increases. In this case, we're talking about a semiconductor. Silicon, if you heat it up, it allows the charges to move. Okay, so we know that must be a semiconductor. It's a property of the semiconductors, and we're going to put the answer of C. Last one, mass per volume. You must know this. Mass divided by volume is density. Okay, grams per centimeter cubed. So 1.1.7. Notice my answer is going to be D. There you've got it. I hope that that's not just giving you an idea of the answers, but a method of tackling these match the column questions. And we've done a little bit of revision at the same time. Megan, I think it's time for a break.
Little bit of a break. Grade 10's revision for you. Don't go anywhere. We'll be back after the break. Welcome back, Mindsetters. Hope you had a good, chilled, laid-back break and are ready to tackle the rest of what we're doing. Today is physical sciences. I bet you are G'd and so excited for this lesson because I'm so excited to be here with Mr. John himself. But now, being silly as I am, I was so confused of where to find the notes, and I'm sure you guys are confused.
Can I show them?
Yes.
Okay, guys, remember, webpage, www.learnextra.co.za. But now we're not on live anymore. We're doing exam revision. So make sure, and I just hope this works this time because I really want to show this to you. You need to be on the orange area.
So orange.
You need to be on the orange area, and you'll see it says exam school. And look here, Megan.
Yes.
There's the shortcut for the link to the competition as well.
How cool is that?
How cool is that? It's amazing. so we've got it all there. Then to check that you're on the right page, it starts at 9 o'clock in the morning. That's all grade 12, all the way down. Grade 12s are doing 9 o'clock, all in blue for today. For green for tomorrow is life sciences. And then what you'll see is after in the afternoon, somewhere around 5 o'clock, that's where the notes are for, and I've gone next week already, but that's where the notes are for matter and the atom. I've just pointed onto it. Now, guys, if you want the notes, what you've got to do is you've got to click, like my finger is pushing, on that blue bar, and there the notes.
Voila.
The notes will come up, and let's make sure that we go through them. So, guys, let's get into the next question. I really want to rush through this next part because we need to get into stuff on the atom. I love the atom, love teaching about it. And if you've got any questions on anything related to the matter and the atom, you want me to discuss it with you, please post on the page. What's that address again, Megan?
www.facebook.com/learnextra with an X.
Excellent. So let's get going. Guys, next one. We're still on question 1. Can't believe it. We've just done matching columns. We're moving on to question 1.2 now, and we're asked to make a little bit of a definition. I'm not going to write out in full sentences because I want to get through as many questions as I can, but also to remind you about changes and about the content that you need to know. So let's read the question. It says solid carbon dioxide. So let's make sure that we've got it. Solid carbon dioxide, remember carbon dioxide, CO2, is something known as dry ice. Steam ice, you might know it as well. And it's under normal circumstances, dry ice sublimes as it warms up. And they ask us to define the term sublimation. Now, this is an interesting word because it's telling us what happens when we go from a solid to a gas. And the word for that is sublimation. It's the phase change when a substance changes directly from a solid to a gas, or when a gas changes directly into a solid without forming a liquid first. So that's the definition. You need to understand it and know it. But at the same time, guys, make sure you define in your own head, and you know that you can define the phase change when something goes from a solid to a liquid. What do we call that? Solid to liquid? Well, that's melting. What about liquid to solid? Liquid to solid, that's freezing. There's a melting point and a freezing point. The melting point and freezing point of a pure substance are the same. There's no difference. They will melt and freeze at that temperature. And then we get from a liquid to a gas, and from a gas to a liquid. Now, a liquid to a gas, we call that boiling, and some people, that's at a particular temperature. We can also get changes from a liquid to a gas at any temperature below the boiling point, and we call that evaporation. You need to know the difference between evaporation and boiling. Boiling is the highest temperature at a particular pressure that a liquid can stay a liquid. If it's beyond that temperature, the liquid cannot survive anymore in that phase, and it's got to change to gas. But evaporation can take place even at room temperature. Water evaporates if we leave it for long enough in the sun. It will evaporate. We might not notice it, but it will evaporate. Okay. What about the going from a gas to a liquid? Well, we call that condensation. So please make sure you know those words and you know where to apply them, and you can use them really well. Right. Now, when you take a block of butter out of the fridge, it is hard. However, after 15 minutes at room temperature, it is soft enough to spread. Use kinetic theory to explain the above observation. Now, guys, kinetic theory is a core of all our understanding of the behavior of matter. What we recognize is that in every substance there are particles, and these particles could be atoms or molecules or ions, but they are in constant motion. They are vibrating even if they're in a solid. They have forces between them, and those forces allow a certain amount of movement. As a solid, at low temperature or a lowish temperature, like the butter molecules in the fridge, they won't be moving very much. That's why it's hard. As the temperature increases, what we recognize is those molecules get more energy. Because they get more energy, they start to bump around. They move a little bit further. They no longer just vibrate on the spot like this, but they start to do a little bit of a jig. And as they do a bit of a jig, they start to weaken the forces between the molecules. So the forces aren't so strong because they've got the energy to move. And the next thing, they'll be floating all over the place because they've formed a liquid and they're able to move freely. And if we allowed it to carry on for a long time, they'd even evaporate and they'd be free up in the atmosphere. Okay, so I am not going to write that down, but what I want you to understand, kinetic theory, all substances are made up of particles. Those particles are in constant motion, even at like 0 degrees Celsius. Only at a very, very low, negative minus 273 degrees, will things stop moving altogether. Okay? But at normal temperatures, things are moving. As solids, they vibrate. If we allow butter to get warmer, then they vibrate further, they can move more freely, and that's why it becomes softer. Okay, move on. Any questions, Megan?
Nope, nothing. They're just so happy about the notes, so
Okay,
luckily you showed
excellent.
them.
So let's go through to this important practical. Now, you should have done this in class, and you would have got a graph like the one I'm going to show you. It's in the notes, so make sure you've got it. I hope that Megan can take a picture of it and put it on Facebook for those of you who haven't got the notes. Right, the graph is critically important. It's called a temperature curve. Okay, it's a heating curve of a substance. And let's go through and see what it looks like. Now, this particular one, because it's drawn, the heating curve of a pure substance, so it's a heating curve, it's a pure substance at atmospheric pressure, is shown in the graph below. Now, I'm just going to draw over it so that we've got a clearer picture that will actually stand out. Because on all these lines, I think you might have problems seeing exactly what we're talking about. So I'm going to just move that there so that we can see the pink line is the line that we're talking about. And we put another pink line in because now it goes to that position. I'm just going to have to adjust it by moving it down. And I'll choose another one to show it going up over here. Notice as this is happening, what are we saying? What is the graph telling us? I hope you can see it because it's going through different stages here. And the last section is like that. So there we go. Let's have a look at what the graph actually says. We say we've got temperature axis over there. We're starting at 30 degrees, then 60, then 90, then 120. And this is time, measured in minutes. Okay, they haven't really told us what the minutes are, but we've just told that there's time there. Now, guys, what do we notice? What's happening? We notice that the temperature increases until it gets to a point. And I'm just going to make a point over there until it gets to that point. And it remains at that temperature for all this time. And I'm waiting and waiting and waiting. And in this experiment, what you would be doing is you'd be actually supplying energy, whether it be under a Bunsen flame or a spirit flame, and the stuff is starting to change phase. It's changing phase, and then we see that the temperature increases only after a certain amount of time, and it increases very rapidly until it gets to another one of these sort of plateau regions. So all of this time, it's in another plateau. And it's the same thing is happening. What you would notice, if you were watching, is the substance would be changing phase. Not all the substance would be in the same phase. Some of it would have changed phase, but there would be some substance that's still in the original phase. So we've got two phase changes. Let's see what they could be. At the lowest temperature, what's the substance going to be? Now, that shouldn't be difficult for you to understand and for you to remember. At the lowest temperature, we always start with things in the solid. So we now apply some heat and we increase the process. We increase the temperature, the solid heats up, and that's what's happening in that phase. Now, in the part that I've shaded over here, what's changing is we're getting a change from solid in that time period. It's going from solid to liquid. So what do we call that process? Changing from solid to liquid? We call it melting. And then, over here, at this temperature, at this exact point there, all the solid has changed to liquid, and now the liquid is heating up. All that's happening over there, the liquid is heating. It's heating up. And what's happening over here? Well, it's changing from liquid to gas. So we have gas at the end, and then this is the change from liquid to gas. What do we call that? We call that boiling. Okay, now this is called melting, and that's called boiling. We've got all the things in. Notice that I haven't answered any questions. I've just analyzed the graph, and I hope you're remembering about all those details. Okay, let's go to it. Write down the following for this pure substance. the melting point. Now notice we've already highlighted it, and what we'll have to do is through the lines just extrapolate off and read that point. We know that there are 30 and there are 10 little blocks here, if I'm not mistaken. 1, 2, 3, is that right? 3, 4, 5, 6, 7, 8, 9, 10. And 10 is 30. That means each one of them is 3. And I've got 2 blocks below. So 60 minus 6, that's going to give me 54 as my melting point. 54 degrees Celsius. What's the boiling point? And here I notice it's at 3 above, 1 above, 1 little block above the 90. So that's 93 degrees Celsius. Okay, guys, reading off the graph is a critical skill. You need to know this. You need to use your ruler. You need to measure carefully, measure exactly what's happening. But let's move on. I was just showing you what the answer was there. Now let's do the interpretive questions. Is this pure substance as water? Now, guys, you should know this. What temperature does water melt at? Don't tell me 53 degrees, because otherwise we wouldn't in the studio have a glass of this stuff here. I couldn't be standing here looking like this at 53 degrees, could I? No, we know it can't be water because the temperature in here is only about 22 degrees today because the aircon's on. But you need to recognize that this can't be water. The melting point is too high. At atmospheric pressure, water has a fixed melting point of 0 degrees Celsius. It has a fixed boiling point at atmospheric pressure of 100 degrees Celsius. If the atmospheric pressure is standard atmospheric pressure. In Johannesburg, we know that water boils at about 94 or 95 degrees, depending on atmospheric conditions because of our altitude. But this is definitely not water. And so we're going to say no. That's the first mark. No. Why? Because the melting point of water, and you should know this from the experimental work that you've done, is 0 degrees Celsius. Okay, guys, that's vital. Let's quickly do the last couple of questions of this one. What is the physical state of the substance at point X? So now look where X is, and the physical state at X. Now, it's a tricky question because it's changing from a liquid to a gas. So at this point, we'd have to say that at X, it is a liquid and a gas because it's boiling. Okay? What about at room temperature? Now, room temperature is 25 degrees. What is that down below there? We've already said it's a solid. So I'm not even going to fill that in. Next point. What happens to the temperature while the substance melts? Well, you've seen that. You've seen it right there. During the melting phase, what's happening to the temperature? The temperature at that point, it's flat. It's not changing. It's staying the same. Megan, over to you.
Ready? Okay, guys, we're going to tend to your questions. I've posted the notes for each of you that have asked, so there's nothing to worry about. Just click on it, and voila, you can follow with John and myself. We'll see you guys right after the break. Welcome back, Mindsetters. Hope you had a good break, but now you're ready to finish and carry on with the rest of our physical sciences. Grade 10, this revision is crucial. I promise you, it's exam revisions. This will do you the world of good. Don't forget, hit us up on facebook.com/LearnExtra. Also, we have Twitter @LearnExtra, and I've told you where to download the notes, but just in case you don't know, it's www.mindset.co.za/LearnExtra with an X, and click on revision, not live shows. There we go.
Thanks, Megan. And guys, don't forget, for great revision content, enter the competition. Click on that marathon competition logo on the website. Now, there was one question that Megan and I were just talking about. The question about why the temperature graph, that heating curve, remains constant like that when there's a phase change. And somebody's posted, is that, what was the person's name? Okay, don't worry. Yeah. Doesn't matter. Sorry about that. I'm moving on.
Renee.
Renee?
Yeah.
Yes, it's latent heat. what's actually happening there is you supplying energy to the molecules. Now remember, we spoke about with the butter. When you supply energy, you allow them to move further and faster and faster, and they move a little bit further. Now what happens when the temperature is constant? The energy has to go into breaking the forces of attraction, the intermolecular forces. And that's what we call it as latent heat. The molecules want to, some of them want to hold on to each other. And so they need to have energy to break that. That's why the temperature remains constant, because temperature is a measure of the average kinetic energy. So only when the temperature is increasing, then the molecules are moving faster and faster because their mass isn't changing. But when it stays constant, what's happening? The energy is still being put in. The flame is still going there. What's it doing? It's just breaking the intermolecular forces. Okay, hope that answers that. Was there anything else? Just give me a simple one.
No,
anyone? Okay,
no.
Don't worry. We'll move on. We'll come back to your questions.
They're very complicated, yeah.
Okay, it's fine. We'll come to them now. I want to do this question, and I want to really get into the atomic stuff. So let's rush through this one. Household name of sodium chloride. Guys, you need to know this. This is table salt. Okay? So it's simply table salt. Let's revise this quickly. This is quick, sharp questions. Chemical formula for sodium chloride, NaCl. You need to know that. Then the Aufbau diagram. Now this is important for chlorine atom. Now the chlorine atom, what number on the periodic table is it? What group does it belong to? Remember, chlorine is one of the halogens. It's in group 17. It needs one more electron to fill its outer shell, its final energy level. Chlorine, we need to recognize is number 17. Okay? Atomic number 17. So when we draw the Aufbau diagram, I'm going to just sketch it very quickly. We need to have 17 electrons accommodated in the structure. And as I said, this is a rough sketch, very rough sketch. 1s, 2s, 2p, 3s, 3p. Now, I hope you don't draw it as badly. You need to draw it with a ruler, and we're going to fill in the arrows that way. Those are 2 electrons in the 1s. That's 2 electrons. We've got 15 to go. Another 2. They fill up like that in the 2s. Then remember Hund's rule. We need to fill them up individually first of all. Now how many have we got? That's 4, 5, 6, 7, 8. Whoop, let's just undo that. Put it back to where it's supposed to be. There's the next one. There's the next one. There's the next one. They have opposite spin in the same orbital. That sublevel, the 2p sublevel, 3p orbitals, and they're paired electrons. So at this stage, we've now got 10. Remember, we want to get 17. 11, 12. Must fill the 3s first, then 12, 13, 14, 15, 16, 17. That's the Aufbau diagram. Now, in terms of that, I wouldn't just ask you for the Aufbau diagram if I was examining. I would ask you to write down the electron configuration as well. So from the diagram, I'd say 1s2, 2s2, 2p6, 3s2, 3p5. And that's the electron configuration of chlorine. It's chlorine atom. It says write down the number of valence electrons. Now, this is easy once we've done that, because what we need to do, valence electrons are the ones in the outer shell. So it's just those ones. So on that structure, it's over there. So we've got 7 of them. It's in group 17, and in the old terminology, we'd say group 7. Okay, next one. For the sodium atom, write down its sp notation. That's electron configuration. 1s2, it's 11 electrons. Sodium is number 11 on the periodic table, and a mass number of 23 or so. 1s2, 2s2, 2p6, 3s1. Number of protons. Well, the atomic number is equal to, let's make very clear of that. The atomic number has a symbol of Z. So we're going to say Z is equal to 11. So their number of protons is equal to 11. Okay, Megan, we're on to question 3.4.
I'm following.
So, represent the formation of sodium chloride in aid of a Lewis diagram. Guys, this is critical. You've got to know this. Not just for grade 10, not just for grade 11, not just for grade 12, but if you ever go to university, you're going to need to know Lewis diagrams. Okay? Remember what we do. We count the valence electrons and we use the symbol of the element to represent the inner electrons. So, for sodium chloride, I'm going to put sodium. It has 11. It has 1 valence electron. I'm going to use the dot for the sodium. Then I'm going to say, right, chlorine. Chlorine is Cl. And I'm just going to do it very simply. I'm not going to do it with the diatomic chlorine, just simply chlorine atom. And I'm going to say, let's make crosses for them. There's 7 valence electrons, so I'm going to put them like that. Now, this is the part that I love about this board, because I can show you how electrons are transferred. So let's hope that it works. I'm going to select that electron and say, sodium wants to give away electrons. So let's take the sodium and let's transfer it to the chlorine. What happens to the sodium now? The sodium is going to become positively charged because it's got 1 more proton than electron. So I write it in square brackets like that. What happens to the chloride? Well, it's gained an electron. It has 1 more electron than it has protons, so it becomes negatively charged. The sodium, sodium is no longer an atom, it's an ion. We say that is a cation. It's positively charged, and we'd say that's for the sodium, is the cation, and the anion is the chloride. Okay, name the type of crystal that will form. Well, it's an ionic crystal because we've got formation between ions. Cation, anion, there's an attraction between the ions. Right, almost there. Sodium, a chlorine atom can also bond to another chlorine atom to form a molecule. Define the term molecule. Now, guys, again, this is really important. A molecule is formed when we get covalent bonding. So when electrons are shared between atoms, they form molecules, overlapping orbitals, and molecules are formed. So it's the sharing of electrons in the orbitals so that we get complete bonding pairs. A covalent bond is formed, and we've got that formation there.
John, after the question 3, do you mind if we ask you a question?
Yeah, sure, we'll take that. Name the type of bond that forms between chlorine atoms. Well, I've just told you, it's a covalent bond. And if we really wanted to be specific, because they're the same, chlorine pulling against chlorine, they're sharing electrons, it would be called a non-polar covalent bond. Final one, represent this in a Lewis structure. Now, I'm just going to do it very quickly. There's one chlorine, there's the other, and I'm going to do the crosses on this side. We can draw crosses or dots, doesn't matter. And we're going to say, let's make the dots on this side. 7, notice, 7 electrons in both cases. There they are. Now, what am I going to do? I'm going to say they're going to share nicely. So I hope that this will work. Let's try again. It wasn't working like I wanted it to. And, come on. No, it's not working. These two are going to move closer to each other. And they're going to, therefore, attract each other. That forms a new bond pair. These two like to be paired. Notice electrons like to be paired. There's a non-bonding pair. There's another non-bonding pair. And this pair here that I've circled in pink, they are the bonding pair. So it forms a single covalent bond. Right, Megan?
Can
Your
I hit
question.
you? Okay, well, a lot of the mindsetters said they really didn't understand 1.1.3, unfortunately. I know it's way back,
Let's
but
go back to it. No
they
problem.
all asked. They didn't understand 1.3, yeah.
Okay, let's
No.
go. 1.1.3, a non-metal element. Guys, if we look at this list, we know copper is not a non-metal. Okay? You've got to choose between sulfur and silicon. Silicon is a semiconductor. It is not a non-metal. This is something that you have to know. Okay? Even though silicon sits in group 14, the non-metals in group 14 are carbon, and then the ones below it, you don't really know. Silicon is a semi-metal. It's not a non-metal. Those are your only two options. So it has to be sulfur. There is no other alternative. And the most obvious one, you can't tell me that sulfur is a metal. It's not a metal. So the answer has to be for sulfur, which was E. So guys, don't pick the non-obvious one. The obvious one there is the one that is more like the noble gases, closer to group 17 or group 18. Those are definitely non-metals. Okay.
Okay, one more go back to 3.6. He says, why not a covalent bond? Because Na is a metal and Cl is a non-metal. Why?
Okay, wait. Let's go.
Oh, sorry. I went too fast.
Where are we?
My apology. 3.6.
3.6.
There.
Okay. It didn't ask for sodium. It asked for or sodium chloride. It said a chlorine atom and another chlorine atom. And that forms a molecule, which we know is Cl2. So it is definitely a non-polar covalent bond because they're sharing of electrons. Remember the difference. Sharing of electrons, covalent bonds form molecules. When we find a transfer of electrons between metal and non-metal, then it is an ionic bond. Okay.
And one more, Bocciolello says, what is the meaning of a crystal lattice?
Okay, crystal lattice, I'm not very good at drawing, but I'm going to try. Okay, so here's a crystal lattice. You just draw a box like this. Okay, and we're going to say at this corner here, we have a positively charged ion. At that corner over there, at that corner, we have a negative. Then at this one over here, we're going to have a positive. And at this one, we'll have a negative. At this one, we'll have a positive. At this one, we'll have a negative. At that one, we'll have a negative. So they don't form a molecule with two atoms only. But there are literally thousands of them. And they form in this structured box-like frame. A lattice simply means that. Lots of them joined together, forces pulling them, millions and millions of them all joined together in the same sort of structure. Hope that answers it.
Perfect. Do you want to carry on?
Okay, let's quickly see.
I think we have a few seconds.
We've got a few seconds. So quickly, let's have a look at this. Information of 6 elements represented P, Q, R, S, T, and Y are given in the table below. Now, guys, you need to do this with the periodic table. And what we've given is element P. It says which element, P, Q, or R, has 22 neutrons. Now, very quickly, got 2 seconds. Remember, protons, electrons, and neutrons. The atomic number is the number of protons. Atomic number is equal to the number of electrons. Neutrons is the number of mass number. Megan, I think I'm out of time.
Are you out of time? Okay, no problem. Mpunyane says she just wants to thank you because she understands now. So.
Excellent. Guys, that's the point. Stay on the page and remember, don't forget, watch us for the next few weeks. We'll be doing Learn Extra Revision at this time.
Awesome, John. Fantastic working with you. Fantastic working with you, of course, Mindsetters. Stay tuned. Grade 11 revision is next. Physical sciences, I can't wait. Don't go anywhere. Have a great afternoon/evening. And that's all from me to you. Cheers, guys.